For this lesson, we're going to be looking at a couple of key concepts from the grade 9 course as part of our continuing review in the grade 10 course. Looking at slope primarily, and also what are the implications of slope as it relates to a line, and how can I use parts of a line or points of a line in order to find slope. Just a quick refresher, a couple of things that you need to remember about slope. In general, when we talk about slope, we're going to identify slope as a number. And that number can be positive, can be negative, and it can actually be a couple of other interesting things. So when you take a look at the lines that we have here, what might you say about the slope of these lines? So in the first case, the slope of this first line is positive. So the slope is greater than 0, or you might just say that the slope is positive. And the reason why we say this is positive, or the feature that identifies that, is that the line is running up and to the right. So when you have that condition, then you have a positive slope. That being said, now we have a line. It's not as steep. You might actually also say for this one that it is a fairly steep line. So not only would we expect the slope to be a positive number, but we would expect it to be a fairly large number. At least it would be a large number with respect to this line. This line is obviously a shallow line, so we would expect the slope to be a relatively small number. And what else can I say? Well, this one is not going up to the right. This line is going down to the right. So if it is going down to the right, then we would say the slope is less than 0, or the slope is negative. That being said, take a look at this third line. So what do we see about this one? It is neither up to the right nor is it down to the right. And so it's what we call a horizontal line. So what does a horizontal line mean with respect to slope? That means that we have a slope of 0. And we can't really talk about the steepness of this line. Having a slope of 0 is the exact opposite to the idea of being steep, or I guess as you get more and more shallow, you could think of that eventually you'll reach a point where you just end up with a slope of 0. So that's for our horizontal line. Here we have a vertical line. And so what about the slope of this one? This would have been a large positive number. This one would have been a small negative number. Our vertical line is like our positive slope steep line, in that if we kept turning this further and further, if I took this and I tilted it more, what could we say if I tilted that more? It would still be positive, and it would be even steeper, which would mean that the number for m would have gotten larger. And I tilt it some more, and it's even steeper, and the number for m has gotten larger. So what's the actual largest value that m could take on? And what we reach then is is it a million? Is it a billion? Is it a trillion? We could keep getting steeper and steeper and steeper until we reach a vertical line where this slope is so large that it becomes undefined. Or it's not even that it's so large, it's that once we reach that idea, some people would say the slope is infinite, but it's better to actually use this word. It's better here to say that the slope is undefined. If you were to say that the slope here is infinite, you would be showing that you understand what's happening here, and that's really the important part. But mathematically, from a communication point of view, we want to say that the slope is undefined. A couple of other things to talk about with regards to slope. What about comparing a slope between two lines? So if we take a look at these two lines, how would you describe those two lines with respect to each other? What would you say? And you might say that those two lines are parallel. The way that we indicate that is we use arrows to indicate that those two lines are parallel. And when I drew this, I meant for those to be parallel. Parallel lines have the property that their slopes are the same. So that would mean that if m1, the slope of the first line, is 2, then the slope of the second line is 2. Let's take a look at this one. We have slope of the first line, which is the blue line, is equal to -1/4. And I've indicated quite carefully that I have a right angle between them. So when you have two lines which are perpendicular to each other, then the slope of the perpendicular line has a very specific relationship with the first line, and that is called the negative reciprocal. So the slope of the second line, M2, is equal to the negative reciprocal of the first line. So the first line was negative, so my new value is going to be positive, and the reciprocal of 1 over 4 is actually 4 over 1. We wouldn't normally write that as 4 over 1, we would just write that as 4. I take a look over here. As it's drawn, this actually doesn't provide us with enough information. I have my first slope has the slope of 2/3. My first line has a slope of 2/3. My second line, I don't actually know that they're perpendicular. I think that this becomes more interesting. As it stands right now, I can't say anything about this second line. But the way they're drawn makes me suspect that I intended for this to be a right angle. And so if I say that's a right angle, then my second slope is the negative reciprocal of the first. So instead of 2/3, I'm going to write the reciprocal, 3 over 2. And instead of it being positive, I make the whole thing negative. And I don't like to mess around. If we take a look up here, I don't like to put that minus sign directly in front of the fraction symbol unless I'm using software, word processing, to do it. Otherwise, it's a good idea to put your negative sign in the numerator. Never in the denominator, in the numerator. And lastly, I've got a vertical line here. My blue line is vertical. That means that that slope is undefined. So what is perpendicular to a vertical line? Well, perpendicular to a vertical line is this red line, which must be a horizontal line. And so the slope of a horizontal line, as we looked at in the previous slide, is equal to 0. Okay, if we want to get into a more algebraically significant form, we're going to be looking at the equation of a line. And I talked about this a little bit in the previous lesson as well. So the standard, this is called the equation of a line in standard form, or slope-intercept form. Sorry, not standard form, slope-intercept form. Y equals mx plus b. And in that we have the slope as m and the y-intercept as b. In a previous tutorial I also warned you, you might see this in slightly different forms. You might see y equals mx plus k. So some people, some conventions use k for the y-intercept. You might see y equals ax plus b. So some people will use the letters a to represent slope and b to represent the y-intercept. These are all equivalent forms. We're just changing around the letters. We do that in math all the time. In our particular class, we're going to try to be consistent using m and b, but I don't want you to be unnerved if you happen to see a situation where these other conventions are used. To calculate slope, we need 2 points. So here's point number 1, x1, y1, and point number 2, x2, y2. To calculate a slope, we make use of the fact that slope is equal to rise over run. And that means how much has the vertical value changed compared to how much has the horizontal value changed. So if I happen to know that I started at x1, y1 and went to x2, y2, in going from y1 to y2, what's the change? That's the rise. And the way we calculate that is we look at where we ended up and we subtract what we started with, and that tells us the change. x2 minus x1 tells me the change in the x-coordinates. And the short form to represent this algebraically is to use the Greek character delta, delta y over delta x. The change in y over the change in x. Once we've calculated our slope, we're going to write the equation with the new slope, and then we'll substitute a point in so that we can find the y-intercept. These second two are going to make a lot more sense when we actually do a practical example. Determine the equation of the line that passes through these 2 points. So the first thing we're going to do is calculate the slope. The slope is equal to the change in y over the change in x, but that's the same as y2 minus y1 over x2 minus x1. So that means I have to decide which of my points is point number 1 and which of my points is point number 2. Just based on the order in which they appear, I'm going to say there's my x1, there's my y1, my x2, and my y2. I could have reversed this. I could have said that this was the second point and this was the first point, and my calculation would still work out in the end. So choose whatever is easier for you. Just make sure you're consistent. x1 and y1 have to go together. x2 and y2 have to go together within the point. So I've chosen y2 to be -3 minus, and when you put in your y1 here, it's probably a good idea to use brackets just in case it's a negative number. No harm this time because it's positive. x2 is equal to 7 minus x1 is equal to 5. So I end up with -3 minus +1, which is just -3 minus 1 is -4. 7 minus 5 is equal to 2. And -4 divided by 2 is equal to -2. So that's my slope. So I've calculated the slope. Now I'm going to write the equation using that slope. So my equation now is y equals, normally we would write mx plus b, but we just figured out that slope is equal to -2, so this becomes -2x plus b. So I've written my equation. Sub a point xy. And really, something I want to point out here is it is sub any point that we have. So we could sub point 1 or we could sub point 2. I'm going to use point 1, but you need to understand that you could have used point 2 and it would have worked just as well. And we want to make sure that we're clear as we document the steps that we're taking here. So I'm going to sub point 1, which is 5, 1. And so what happens when I sub point 1? Well, remember, this is my x value and this is my y value. So instead of y, what do I write instead of y? I actually write the number 1 equals -2, and instead of an x, I'm going to substitute x was equal to 5. And that's going to be plus b. The reason why we're doing this is because we're trying to solve for b. So I just went ahead and I subbed a point. Now I have to do this step, solve for b. So I end up with 1 equals -2 multiplied by 5 is -10 plus b. And now we have a little equation here to solve. And so how do I move this -10 from the right side over to the left side? Because I want b isolated, I want b by itself. And the way that I do that is I'm going to add 10 to both sides. Add 10 to both sides. 1 plus 10 gives me 11 is equal to b. So there we go. I've solved for b. Over here, I had solved for m. Here, I've solved for b. And now finally, I can rewrite my equation. Y equals mx plus b is actually going to become y equals -2x plus 11. And there we have the equation of that line. Okay, just another example here. I'm going to go through this one a little bit more quickly. The slope is equal to y2 minus y1 over x2 minus x1. This is going to be my x1, this is going to be my y1, this is going to be my x2, this is going to be my y2. So that is equal to y2 is 7 minus y1 is 6. Again, I could put brackets there. When it's a positive number, you don't need brackets, but when it's a negative number, it's a really good idea to put brackets there. I have -1 minus, and it's this subtraction, that's why we're worried about a negative number, minus 2. 7 minus 6 is equal to 1. 1 minus 2 is, negative 1 minus 2 is equal to negative 3. And we don't normally like to leave the negative sign in the denominator, so I'm going to write that as negative 1 over positive 3. So that's my slope. Calculated the slope. Now I'm going to write my equation. Y equals negative 1 over 3 multiplied by x plus b. Sub a point, so I'm going to sub the point P1, which is 2, 6. And so my y value is actually 6, is equal to negative 1/3 multiplied by, instead of x, it's going to be multiplied by 2 plus b. We're introducing a fraction here. It happens sometimes. We don't always get really nice answers. So I get 6 equals negative 2/3 plus b. Now I need to move this negative 2/3 over to the other side. So this is another way to think of it. When you have, instead of the way I did it in the previous question where I added 10 to both sides, now I'm going to imagine that I want to move negative 2/3 across the equal sign. Whenever a term using addition or subtraction crosses the equal sign, you change the sign. So this becomes 6, and instead of minus 2/3, this becomes plus 2/3 equals b. Now, in order to do this, I'm going to need a common denominator. And the thing to keep in mind is that when we have 6, remember, any whole number like that is actually over 1. So how do I change that to a number over 3? I have to multiply the 1 by 3. So I multiply the 6 by 3, and I end up with 18 plus 2 over 3 equals b. And I'm just going to move this up here. So 18 plus 2 gives me 20 over 3 is equal to b. So I've subbed my point. I've now solved for b. And the last thing I need to do is rewrite my equation. It becomes y equals negative 1/3 x plus b, which is plus 20 over 3. Done. So I found the equation that way. I think we have one more example to do here. A horizontal line through 5, 2. Well, that's interesting, a horizontal line. Calculate the slope. How are we going to calculate the slope? We only have 1 point. But we make use of the fact that we already know from our discussion before, and if you think back to grade 9, a horizontal slope has the property that slope is equal to 0. So if we can start with that, a horizontal line has a slope of 0, then what is our equation going to be? Y equals mx plus b. Y equals 0x plus b. Well, then we just end up with y equals b. So that's kind of odd, but that's our equation. Then we get asked to sub a point. Well, this is kind of easier than it was before because we have a single point. So I'm now going to sub 5, 2. Well, this is my x value and this is my y value. The y value, sorry, that's kind of covered something up. There's my x value, there's my y value. The y value is 2 equals b, but I don't actually have anywhere to put the x value. I only needed the y value here. And by doing that, I did solve for b. So I subbed that point, I solved for b, and so now my equation becomes y equals b, but I know that y equals 2. So that's telling me that the equation of this line is y equals 2. This is the equation of a horizontal line. The slope is equal to 0. And so that means, if we just do a very quick little sketch here, what this means is that the y value is always 2. No matter where I go along this line, my y value is always 2. Well, that's a horizontal line. So that makes sense. This is telling us the y value is always 2. This also gives us a bit of a hint. What happens if we have a vertical line, which I believe will be the next one. A vertical line through 5, 2. Now for this one, maybe to get your head wrapped around it, you might actually even want to start with a little sketch. It goes through the point 5, 2. 1, 2, 3, 4, 5, 1, 2. So it goes through this point. And it's a vertical line. Well, what does that mean for it to be a vertical line? That means it's going to look something like that. So having that sketch in mind, knowing that's the point 5, 2, we're still going to go through this mathematically. Actually, no, we need this understanding of the sketch in order to come up with this. Calculate slope. Again, this one's a bit of an odd one. What is the slope of a vertical line? The slope is, and we talked about this before, it's undefined. So this one's worse because now when I try to go y equals mx plus b, the slope is undefined. What do I put here? Doesn't make any sense. I can't do anything with it. And so I actually do need to go back to my sketch and try to make sense of it, particularly in the context of our horizontal line. My horizontal line, the thing that made this a horizontal line was the fact that the y-coordinate was always equal to 2. So now if we put that into context, that's why we did this one last, what is the defining feature of this vertical line? And the defining feature of this vertical line is that the x-coordinate is always equal to 5. So it turns out we can't actually do anything with that equation. We just have to use our understanding to say that the equation of this line is x equals 5. So that is the equation of a vertical line. And if I'm not mistaken, I think that's it. Yep, then I've just got some assigned homework. Okay, so we went through 4 different examples there of how to find the equation of a line. The last one here, vertical line, definitely the most difficult one, the one that students have the most difficulty with. But if you remember what you do for horizontal lines, you should be able to work your way through these vertical lines as well.